Hello students, welcome to Infinity IAS. Today we will look at the second part of a previous video where we have discussed the different types of orbits. Today we will look into the comparison of three types of orbits, specifically the geosynchronous, geostationary and the polar orbits. In the previous video we have already seen that geosynchronous and geostationary orbits are high Earth orbits. Polar orbit is a low Earth orbit. What does this mean? High Earth orbit means the distance from the Earth surface is very high for geosynchronous and geostationary, whereas that of the polar orbit is low. If we see, the distance from the Earth's surface is approximately 30 synchronous and geostationary satellites. Though for geosynchronous, the distance might vary, why we will see later. Whereas for the polar orbit, the distance from the Earth's surface is around 500 to 800 kilometers only. So this is a low Earth orbit, these two are high Earth orbits. Now we will see the comparison between these two kinds of orbits first, and then we will compare this to the polar orbit. So if we see, this is the geostationary orbit and this is the geosynchronous orbit. So here we see geosynchronous is an elliptical orbit, whereas geostationary is a circular orbit. Here if you see, this is geostationary and this is always circular in shape, whereas geosynchronous can be elliptical. It need not necessarily be circular. So it can be like this, elliptical, not necessarily circular. So the shape might be different between these two orbits. Next comes most important point, velocity, angular velocity. So for both geosynchronous and geostationary orbits, the angular velocity is equal to that of the Earth. So what does this mean? Here if we see, this is the equator of the Earth and this is a satellite on the geostationary orbit. So here, if the satellite moves 10 degrees on the orbit, so this is 10 degrees. If the satellite moves 10 degrees, the Earth also moves 10 degrees. So the angular velocity is equal to that of the Earth. So what is the angular velocity of Earth? So Earth moves 360 degrees. That is one full rotation in 24 hours. That is one day. So Earth takes one day to complete 360 degrees rotation. So if it is equal to that of the Earth, so the satellite on geostationary or geosynchronous orbit will also take the same time. So for the satellite on the geostationary orbit to complete one revolution around the Earth is equal to 24 hours. That is what we see here. Time taken for one revolution is equal to 1 day because the angular velocity is equal to that of the Earth. Next comes the angle of inclination. What is the angle of inclination? So if we see, this is the equator and this is the geostationary orbit. So geostationary orbit is parallel to that of the equator. It is at a height from the equator, but it is parallel to that of the equator. So there is no angle made by geostationary orbit, whereas this is our geosynchronous orbit. So geosynchronous orbit makes an angle with the equator of the Earth. How? So this is the equator of the Earth and this is geosynchronous orbit. So it makes an angle here between between the axis of the geosynchronous orbit and the equator. So this is the angle of inclination. So if we see, the angle of inclination is not 0 for geosynchronous orbit, whereas for geostationary it is 0. So this is a very important difference between geosynchronous and geostationary orbits. So this is very important. And because of the angle of inclination being 0 for geostationary satellite, the satellite appears stationary. So here we have seen that if the Earth rotates 10 degrees, the satellite also travels 10 degrees. So a person standing here will always be looking straight towards the geostationary satellite. So how does that appear for the person on the Earth? It appears that the satellite is stationary in the sky because it travels along with the Earth. So for a satellite in the geostationary orbit, the satellite appears stationary to a person standing on the Earth. In fact, the name geostationary comes from this fact. Now if we see geosynchronous orbit, the satellite does not appear stationary because here there is an angle of inclination. So it will move up or down. So the person standing here might not always look at the satellite in the same place. So it does not appear stationary. So now with this background, we will compare this to polar orbits. So here we know geostationary satellite is like this. It is parallel to the equator. This is the polar orbit. Polar orbit means the orbit moves over the poles of the Earth. And also if we see, geostationary orbit is a high Earth orbit. Polar orbit is a low Earth orbit. So if we see, the distance of this orbit from the surface of the Earth is very high, whereas polar orbit is very close to the surface of the Earth. And then that is what it is given. See, distance from the Earth's surface is around 500 to 800 kilometers. And then we will go to the shape of the polar orbit. Shape of the polar orbit is not circular. See, if we see, geostationary orbit is circular, whereas polar orbit is not circular. Though in this diagram it appears that the orbit is circular, in the real time it is not circular because after the satellite completes one revolution around the poles, it will shift. It will shift one sector to the other side. So it is not circular in shape. And also polar orbit can also be at an angle to the Earth. It need not necessarily be going right angles to the equator. So that is what here the angle of inclination is not 0. So this is the equator. This is the angle of the polar orbit. It is not 0. It can be 90 degrees, or if it is a little bit inclined, it can be lesser than that. So the angle of inclination is not 0 for polar orbits. Next comes time taken. How is the time taken for one revolution calculated? It is calculated based on the angular velocity, as we have seen with these two orbits. So polar orbits do not take 24 hours to complete one revolution. Some polar orbits take almost 99 minutes to complete one revolution. So it need not necessarily be one day. It will be lesser than one day. So one advantage that we have with polar orbits is that the time taken for one revolution is very less and it is very low Earth orbit. So it is easy to visualize the Earth's surface. And this brings us to the next point, where we see the uses of different types of satellites. So polar orbit satellites revolve around the Earth very fast, covering a large surface of the Earth and also very close to the Earth. So polar orbits are used for Earth observation satellites or imaging satellites. For example, Cartosat is an Indian satellite that is launched into the polar orbit. So this is the use of polar orbits. Now we saw geosynchronous and geostationary. These are very high Earth orbits and they cover huge surface of the Earth. So they are used for navigation satellites or weather satellites. They can be used to visualize a huge area of the Earth and continuously monitor weather or provide navigation services. Here we have our Indian navigation system IRNSS. In the IRNSS, we have both geosynchronous and geostationary satellites. It is a navigation system and we have these two kinds of satellites in IRNSS. So this has already been asked in the prelims examination previously. So this is how we can answer such type of questions. So if you see, these are the important differences between these three kinds of orbits. Thank you, students.